Okay, today's lesson is all about trigonometry. Trigonometry is related to right triangles, and we're comparing certain trigonometric functions to the sides of the triangle. Okay, so the first thing that we need to do is we need to identify the sides and the angles. There are going to be two choices here. We have our triangle here on the left, where theta, which is the circle with the line through it, theta means the angle. Okay, so this is the Greek symbol for theta, and theta means angle. Or we could have theta here in the top of the triangle. Okay, now these sides are going to be related to wherever the angle is. So you have to watch where your angle is. Okay, now if I look directly across my theta, or the angle, that is the opposite side. Okay, the opposite side. If I look at the side next to theta, that is the adjacent side. The adjacent side. And of course, our hypotenuse is always directly across from our right angle. Okay? So, wherever theta is, look directly across, and that's the opposite side. Right next to theta is the adjacent side, and across the right angle is our hypotenuse. Now, that changes a little bit with the other triangle because theta has moved. So directly across from theta, this side is considered the opposite side. This side to the left is now considered the adjacent side, and the hypotenuse will always remain the same. It is always across the right angle. Okay, so these are the sides that you need to know because we're going to be making comparisons for the trig functions. These are our three trigonometric ratios. The first one is called sine, and it's spelled S-I-N-E. We shorten it to sine of theta. So this is the equation part of it. And the sine of theta compares the opposite side to the hypotenuse side. Okay, so that's why we labeled our sides based on the angle, wherever the angle is. Then we want to compare the opposite side to the hypotenuse side. Next we have cosine. Cosine is spelled C-O-S-I-N-E. And the cosine of the angle compares the adjacent side to the hypotenuse side. Adjacent side to the hypotenuse side. And then we have our tangent. And tangent is going to compare the opposite side to the adjacent side. Okay, all of these sides depend on where the angle is located. Okay, then we mark them opposite, adjacent, and hypotenuse. One mnemonic to help you remember which trig function compares which sides is one called Sakatoa. And it was supposed to be this big, great Indian chief that helped out the Americans in the war. So Sakatoa was meant to help you remember the trig ratios. The SOH, well, that stands for sine, and to compare opposite over hypotenuse. CAH, that was meant for you to remember cosine, that compares adjacent to hypotenuse. And then TOA, which represents the tangent, and that compares the opposite side to the adjacent side. So there's Sakatoa to help you remember which trig function compares the sides. Okay, so the trig functions are meant to help you find missing sides and missing angles of right triangles, provided you're given either the angle or at least two of the sides. So the first thing that I do is I go ahead and label my sides. So I'm going to locate my angle. My angle is 35 degrees. And directly across from that is my opposite side. So I know X is my opposite side. Well, 59, that's directly across from my 90-degree angle, so I know I have my hypotenuse side. Okay, go ahead and label and identify your sides based on the angle because that will determine which trig function you're going to use. So if I write SOHCAHTOA, just to help me determine, I'm going to use, let's see, I'm given the opposite side and the hypotenuse side. So I want to look and see which one uses opposite and hypotenuse. Well, it looks like I've got that with the sine. Cosine does adjacent and hypotenuse, and tangent does opposite over adjacent. So I know, based on the sides that I've labeled, that I'm going to be using the sine function. Okay, so I'm going to set up my problem. The sine of 35 degrees equals the opposite side, which is x, over the hypotenuse, which is 59. Okay, now we can solve this using ratio and proportions. All I have to do now is put my sine function over 1, and now I can cross multiply. I'm going to circle that, and I get the 59 times the sine of 35 equals, and I cross multiply the other direction and I get x. Now from here we're going to use our calculator. Okay, now most of your phones have the trig functions. Just make sure you are in degree mode. Okay, and so all I have to do is type that in. 59, there is a sine button, 35 degrees. It depends on if you use your phone calculator or you use the graphing calculator in the classroom. X is going to equal 33.8 yards. Okay, so that means across my little lake with the triangle here is 33.8 yards. Okay, with this example, again, I want to label my sides. So here's my 10-degree side. That means directly across from it is my opposite side. I don't have a value there, so more than likely I'm not going to be using it. 500 would represent the adjacent side. And then across from my right angle is my hypotenuse. Okay, well, I'm going to be using the hypotenuse in the adjacent side. So if I go back to SOHCAHTOA, let me see which one's going to help me. I have adjacent and hypotenuse. That looks like I'm going to be using the cosine function since cosine uses adjacent and hypotenuse. And I'm going to go ahead and be setting up that problem. So I'm going to be using the cosine of 10 degrees equals the adjacent side, which is 500, over the hypotenuse, which is x. If you'll remember, we're putting this over 1 to create our proportion. Now I'm going to show you a little trick. I'm going to go ahead and solve this out. It's going to take quite a bit of work, but keep in mind when you solve these in the future that when your x is in the denominator, if you will just switch places with the trig function, then you can solve the problem without having to do all this work that's coming next. So normally we would go ahead and cross multiply, and if I do that, I get x times the cosine of 10 degrees equals, and I would cross multiply the other direction and get 500. Okay, next I got to get x by itself, which means I have to divide by cosine of 10 degrees. That cancels it on the left and puts it in the denominator. So now I get x is equal to 500 over the cosine of 10 degrees. So now hopefully you can see why I say if you just switch places, because what happened was here's the original equation here, and here's what I need to evaluate here. The only difference is these two switched places. Remember, they're switched from the original. So I did all of this work to find x, and all I really needed to do to cut this part out was to switch places. So in the future, if your variable's on the bottom, you just need to switch places with the trig function and then solve. Okay, so now I need to get my answer by using my calculator. And x is going to equal 507.6 507 feet. So that ramp there, the hypotenuse, is going to be 507.7 feet. Sometimes we're given 2 out of the 3 sides and we need to find the angle measure. Okay, so still using the angle measure here, I still want to identify the sides because there's my angle and directly across from it, that's going to be my opposite side. Now 12 represents the entire length down here, but I need the right triangle. So I'm going to split that into 6 and 6. So it's 6 feet on this side, 6 feet on this side. And that makes the 6 feet the adjacent sides. Okay, so if I go back to SOHCAHTOA, which is to help me remember which trig functions compare the sides, I have opposite and adjacent. So if I want to look at my trig function, opposite and adjacent looks like it's going to be the tangent function. So I'm going to set up my problem using the tangent. So I'm going to have the tangent of x degrees, and that's going to equal my opposite side over my adjacent side. So that's going to be 3 over 6. Now, I have to do the opposite of the tangent function, and each trig function has an opposite function. And this one's going to be the inverse tangent. Okay, it's got a little -1 there. And I'm going to take the inverse tangent of tangent x, and whatever I do on one side, I have to do on the other. I'm going to take the inverse tangent of 3 over 6. Okay, that allows me to cancel out the tangents and give me x, which is my degree measure. Now, in your calculator, you're going to type this in. If you have a calculator on your phone, some of them have the inverse functions, some of them don't. The graphing calculators that I have for use in my classroom, they do. They have it right above the original functions. So, the answer is going to be 26.6 degrees. Okay, so the other trig functions have opposite functions as well. So if you have to take the opposite of sine, then you're going to take the inverse sine. If you have to take the opposite of cosine, you're going to take the inverse cosine. So their opposites match. Okay, let's find the angle of measure of angle y. So y is going to be my angle measure. So I want to label my sides. So directly across from y, that's my opposite side. Probably not going to be using that. There's no value there. My adjacent side is going to be the 11, and that means my hypotenuse side is going to be 15. So if I look at SOHCAHTOA, I want to determine which one of these trig functions I'm going to use. And I have the adjacent side and the hypotenuse side. So that means I'm probably going to be using my cosine. And I'm going to set up my problem. Cosine of angle y equals adjacent over hypotenuse, which is 11 over 15. Okay, since I'm using cosine, I have to do the opposite of cosine. So I'm going to do the inverse cosine on both sides. Equals the inverse cosine of 11 over 15. What that allows me to do is cancel out the cosines, and that leaves me my angle y. And then I have to type in the inverse cosine of 11 over 15 into my calculator. My y degree is 42.8 degrees.